సరే సైలెంట్గా ఉండండి. Good evening, Professor. We are a group of 6 members, and our project is improving image segmentation using convolutional neural networks with attention mechanisms. And going into introduction, image segmentation is the process of dividing an image into multiple segments or regions, like each one is correspond to the distant object or part of an image. And let me give you some definitions. Like object recognition is to identify various types of objects in the image, and image editing, which is used to edit the image, such as removing the background or changing the color. In the medical imaging, it is a technique to detect and analyze the various types of cancer cells in the different parts of the human body. And autonomous driving is to detect the various types of object and identify its types of control to control the vehicle and ensure safety. In coming to robotics, it is to identify objects in the surrounding environment, which helps for the robot's movement. In going into introduction, there are several types of image segmentation techniques used in computer vision, and some of them are thresholding. In this technique, a threshold value is selected, in which the pixels in the image are separated into two categories: the one above the threshold value and the one below the threshold value. Region growing. In region growing, an initial set of pixels is chosen, and then neighboring pixels with the similar characteristics are added to the region iteratively until like no more pixels can be added to the region. And the edge detection techniques are used to identify the sharp transitions or edges in an image. In clustering techniques such as k-means clustering are used to group pixels in the image based on their similarity. Like the pixels in the each group can be considered as the belonging to the same object or region. And the watershed algorithm is a technique that uses the image gradient to segment an image. Graph-based segmentation, an image is represented as graph, where the nodes and edges represent the similarity between the other pixels. And the deep learning-based segmentation, this technique involves a CNN, which means the convolutional neural network, which have become very popular choice for image segmentation task due to their ability to automatically learn and extract complex features from images. CNN-based image segmentation algorithms typically involve training a deep neural network to learn a mapping between the input image and its corresponding segmentation mask. The network is typically composed of multiple convolution layers, followed by pooling layers, and then fully connected layers. And the motivation is continued by my friend Manju.
When it comes to motivation of the project, CNN-based segmentation has the advantage of being able to automatically learn relevant features from the input data without the need for explicit feature engineering. CNNs can learn hierarchical representations of the input, enabling them to capture complex spatial relationship between different parts of the image. It has been shown to outperform traditional segmentation methods on a variety of challenging datasets, including medical images, natural scenes, and aerial imagery. And when it comes to the problem statement, the main goal of this project is to improve the accuracy and speed of image segmentation using convolutional neural networks. In this, we will investigate the use of attention mechanisms such as spatial attention and channel attention to enhance the CNN's ability to learn and to extract features that are crucial for image segmentation. We hypothesize that by incorporating attention mechanisms into the CNN model, we can improve its accuracy and speed for image segmentation tasks. Next will be continued by Narasimha.
When it comes to methodology, to implement baseline CNN models and evaluating its performance on standard benchmark datasets, we will use computer vision toolbox in MATLAB. We'll then explore different training algorithms such as SGD, and ADAM and compare their performance on the benchmark datasets. We'll study using various learning rate batch size, and also we'll investigate the use of attention mechanisms to improve the accuracy and the speed of the image segmentation. And further, we will study the accuracy and prediction of CNN model and dataset. And coming to approach, data preparation. Preparing the input images and corresponding ground truth segmentation masks for training and validation. This may involve pre-processing steps such as resizing, normalization, and data augmentation. And coming to network architecture, define the network architecture for the CNN. The architecture typically involves a series of convolutional and pooling layers that learn features from the input image, followed by one or more upsampling layers that generate a segmentation mask of the same size as the input image. And the training, we will train the CNN on training dataset using a loss function that measures the difference between predicted segmentation mask and the ground truth mask. And and validation. Evaluate the performance of the CNN on a validation dataset to monitor training progress and detect overfitting. Metrics such as intersection over union and mean average precision are commonly used to evaluate segmentation accuracy. And when it comes to testing, applying the trained CNN to new images to generate segmentation masks. And next will be continued by Srija.
Okay. Coming to attention mechanism, it is a class of techniques used in machine learning that enables neural networks to focus on specific parts of input sequence when making a prediction. There are two types of attention mechanism used in CNN: STN, CAM. STN spatial transform network. The STN consists of localization network and transformation grid. The localization network learns to predict the parameters of the transformation grid, which is used to transform the input images before passing through the rest of the network. And when it comes to channel attention mechanism, it's learns to assign the weights to different channels of the input future maps. And STN has three main components: localization network, generator, and sampler. So localization network, it is the first component of STN. It is a convolutional neural network that learns to predict the parameters of the transformation. And grid generator, it is used to create the sampling coordinators based on the predictor parameters from the localization networks. And sampler, which is performs the actual spatial transformation by using the sampling the coordinates generated by the grid generator. And when it comes to CAN, it has three steps. So global pooling, two function fully connected layers, channel reweighting. So pooling, the future maps are globally pooled. So when it comes to fully connected layers, the pooler maps are then passed to the two fully connected layers. So on lash one channel reweighting, it is used to reweight the future maps before they pass it to the next layer of the network. Next one continued by the Dharma.
Sorry, I'll be continuing next. So this is the code which we are implementing. So in this code, we'll be going through the first output of this code. So first thing, so this is we'll be implementing a CNN model on the training dataset using various layers as discussed. So this figure shows the training graph with two epoch, like which is 32-bit minimum batch size, and the dataset contains around 10 classes, and each class contains around like 100 images. So each image has a specific pixel size, like average like 64 into 64 into 3 pixel, and the learning rate of the basic image is 0.1. So this accuracy of the trained model is around like 60%. So this shows the graphs of the classification of the images using different neural networks. And coming to this confusion matrix, this is a matrix like which is used for evaluating the performance of a classification model, where and represents a target class. So this matrix compares the actual target values with those predicted by the machine learning model. So a good model is one which has the highest TP and TN rate. And coming to the FP and FN rates, it should be low when it is a good model. So now going to the code. So this is the entire code what we have developed. So these are the datasets what we have used and we have downloaded and extracted using this. And coming to the code, we have used three kinds of images like labels, images, and numericals. And so based on that, we have tried different data sets by giving different kinds of images. So by this, the neural networks can identify the different parts of the images and they will specify what kind of image is that. So finally, for our output, we took a like we took a road and we identified different images like the road signals, a person bicycling, and the sky and the building pole. So using this convolutional neural networks, it will specify very accurately comparing with the other techniques. So the accuracy will be around 95% of this code. Yeah, that's all about the code. Next, Dharma will conclude this.
Hello, Professor. We have my teammates are introduced everything about the project, which is improving image segmentation using the convolutional neural networks with attention mechanisms. In conclusion, the implementation of this project has undoubtedly revolutionized object detection, recognition, and segmentation in visual data. And the advent of fully convolutional neural networks architectures and the integration of skip connections, attention mechanisms, everything have significantly elevated segmentation and the accuracy, robustness, and efficiency. And we have included the demanding need for the large label datasets, susceptibility to overfitting, and the computational complexity of training and inference. Moreover, the interpretability of CNN future work could focus on exploring more sophisticated attention mechanisms, which will enable the selective future or region attention, ultimately enhancing model performance and interpretability. And additionally, investing the potential of multimodal attention mechanisms, which can leverage the information from various sources such as RGB and depth images or multimodal medical imaging data, which holds the promise in pushing the boundaries of image segmentation. And this is all about the conclusion and the future work which we have mentioned. And this is the references which we used for to develop this project. That's it. Thank you.